I'm starting it on a new page. All right, but we're going to go through things. I think you should have this in your books, right? That's what I asked you to do. Just copy this down. All right, I'm going to have to use this purple pen now. It's the only one I have. I hope it works. All right, guys, we said yesterday that 180 plus x is in the third quadrant. Right, that is always our first step. We have our cast diagram on the side to help us. We're going to put our 3 there. We know that cos in the third quadrant is negative, right? So we're going to change this to negative cos x. Okay, that was the one that we did together. All right, then 360 minus x. Which quadrant is that in? Quadrant 4. What is sine in the fourth quadrant? Negative. So this is going to turn into negative sine x. Right, because sine of 360 minus x and sine of x will give you the same value, but you have to make it negative. Yeah. Okay, sure. All right, then we divide that by, now we have sine of 360 plus x. Now guys, that isn't one that we put on our cast diagram, the one that we drew yesterday, but which quadrant do we think that will be in? Jasper? The first quadrant, hey? Remember that x is always an acute angle. Remember I said that we have to now assume that unless they specify or unless they say that it isn't. Okay, so if we have 360 degrees, say we're starting at 0, we go to 360, we're basically ending up at 0 again, right? Remember 0 and 360 is the same place. And now we're adding an acute angle to it. Does that make sense that we end up in the first quadrant again? Okay, so this is quadrant 1. And what is sine in the first quadrant? Positive. So this just becomes positive sine x. Okay? Cos 180 minus x. Which quadrant is 180 minus x in? Quadrant 2, hey? Remember, because that's 180, and then we're subtracting an acute angle. That will get us in the second quadrant. What is cos in the second quadrant? Negative. So we change that to negative cos x. Okay, so guys, we're not actually drawing triangles and so on, right? We're just reducing all of these angles that are bigger than 90 to acute angles, like I said yesterday, so that we can actually cancel them out. Okay, because now we see that we have a sine x at the top here and we have a sine x at the bottom. Since I have one term and one term, I can cancel those out. Right, we'll talk about the negatives just now. Here I have a negative cos x and there I have a negative cos x. So I can cancel those out completely. And what am I left with? 3 and a negative 1. So what is my answer there, guys? Negative 3. Okay, that's how we use the reduction formula. Any questions that you want to ask me at this point? Yes. No, minus 3 is the value of this whole expression simplified. Yeah. We are going to get to solving for x when we do trig equations later on. Okay. Damon, do you have a question? Okay. All right, guys, any other questions on this? We're going to do some more examples now, all right, and we're going to practice this. So let's look at number 2. Again, we have to simplify. Sine squared of 180. It's again a fraction, guys. I'm just writing it quite big. So this is the numerator. It just depends on what they give you in the question. Yeah, they can give you any variable to represent the angle. I'm just going to draw my cast diagram here on the side again. It is quite useful if you have it there, instead of trying to remember every time, oh, what happens in quadrant 2, what happens in quadrant 3. All right, if you just draw one very quickly, then you can just use it. Now, guys, for this example, I want us just to write at the top there, just rewrite sine squared of 180 plus theta like this. Right, it looks very complicated, but you'll understand why I'm doing it in the next step. And then here, instead of writing it as cos squared, I'm going to write it as cos of the whole thing and then squared like that. Okay, we should know that these mean the same thing. You can put the squared on the outside of the whole thing, or you can put the squared on top of the sine or on top of the cos. Okay, they mean the same thing. Okay, we see that we need to simplify this. So obviously, if we want to be able to cancel stuff out, maybe add things together, like we see here, they're saying we must add this and this. All right, we can only do that if they are simpler, if we don't have compound angles, if we don't have multiple things in these brackets. Okay, so let's do our whole thing. First, we're going to figure out which quadrants they're in, and then we're going to take the signs. So 180 plus theta is in quadrant 3. So this one is in quadrant 3. Guys, what is sine in the third quadrant? Negative. So this is now, oh, where did I put my pen? We are now going to write it like this, please. Negative sine theta squared. So instead of putting the squared on the side, please write it on the outside. I'll show you now why you have to do that. Plus, okay, now we have cos squared of 180 minus theta. Which quadrant is that in? 180 minus second quadrant. What is cos in the second quadrant? Negative. Okay, now at the bottom here, again, 180 minus theta, again, is in the second quadrant. And what is tan in the second quadrant? Negative. So this is negative tan theta times, we look at cos there, 360 minus theta is in quadrant 4. Yeah, and cos is positive in the fourth quadrant. Okay, so that one just becomes positive cos. You can put it in bracket if you want. Okay, but you don't have to. I usually just put brackets around them so that I don't lose track of the minuses. Okay. Now, guys, what do you get when you square anything, even if that thing is a negative? It will become positive. All right. That is why it's important here that when you are changing this sine squared to a negative sine squared, please need to put the squared on the outside of the bracket, because this is now actually just going to become positive sine squared. Okay, because you all know that even if you take negative 2 times negative 2, you get positive 4. If you take negative sine times negative sine, you're going to get positive sine squared. Okay, so please, for these two, I'm just going to write here sine squared theta, cos squared theta, and tan also. If there was a tan in here, the same thing would happen. Will always be positive. Just because when you square something, it will automatically become positive, sorry, whether it was positive or negative to begin with. Okay, so I'm just going to rewrite this now. This is going to become sine squared theta plus cos squared theta which is what? 1. Okay, so in the next step, we are going to change that to 1. What's going to happen at the bottom there, guys? We are going to, if we're just thinking in terms of trying to simplify this, right? In the previous example, we just had one term over one term, so we could cancel out or be using algebra. All right, in this case, we don't have that. We don't have one term at the top right now. Okay, it is going to become one term because I'm going to write it as a 1. But then I can't cancel, if I have 1 at the top, that's not going to cancel anything out at the bottom. Okay, Jack, what do you want to say? How am I going to do that? Yes, I'm going to change the tan to sine over cos. All right, Jasper, that's what you said as well. So we're going to change this tan theta to sine theta over cos theta. Just remember that it was negative tan theta, so we have to put that minus there again. And that was times cos theta. Okay, now we see that we have a cos theta over there and a cos theta over there. They're going to cancel each other out. And this, my numerator is going to become 1. So what is my final answer going to be, guys? What's going to be left at the bottom? Negative sign, but we need to put that minus in front. Okay, so let's make it negative 1 over sine theta. Okay, because it would be 1 over negative sign, but then we just need to put that minus in front. Okay. I'm going to do another example because, yeah, yesterday was a bit rough. So let me just quickly see. Yeah, but remember, we don't work with the reciprocal. So you can change it if you want, but you don't have to. This is 1. Sine squared plus cos squared is 1. So that's where that 1 comes from. Okay, guys, are we fine? There's some chatter. Do you have questions? This 1 comes from sine squared plus cos squared theta. We remember that square identity. Sine squared plus cos squared is equal to 1. Okay, so I didn't actually cancel it out. I just changed it using that identity. And then at the bottom, I had negative sine theta. Okay. Let's do another one quickly. I actually want you guys to try this one on your own, and then we'll mark before I give you work to do. Sorry, I'm just checking. This is actually the same, so I'm going to change it to Okay, do that one on your own for me, please, guys. Draw your class diagram on the side just to help you. Okay, can we take a look? All right, there we go. That's what I got, -3/2. So do we agree that 360 minus x is in the fourth quadrant? And sine is negative in the fourth quadrant. All right, so that changes to negative sine x. That's the first thing. Then you could have done times 3 and then in brackets negative cos x, but you see what I did here? I just realized this is all one term, hey, the whole thing actually. So if this becomes negative cos x, you can just as well write -3 cos x, but it doesn't matter. You can just put a 3 and then bracket 180 plus x is in the third quadrant. And cos in the third quadrant is negative. All right, so that needs to become negative cos x. At the bottom, we have the same thing. Did you guys notice that? Again, we have cos 180 plus x. 180 plus x is in the third quadrant. So that is again going to become negative cos x. And then we have 2 times sine of 180 minus x. 180 minus x is in the second quadrant. And sine is positive there. You know? So that just becomes positive sine x. Could have just left it in brackets. Then what I did was I just saw that I have a negative times a negative. That's going to become a positive. That's why I just kind of drew lines through those minuses. But then you still have a negative at the bottom. So you have 3 over -2. Yes.
I mean, not the numbers that outside of the bracket.
Yeah.
I did the same thing, but then I got -1 on the top and times 3 and it doesn't matter which.
No, it doesn't matter. It's fine. Yes.
So now when we have a number, like we call it, like we put it inside the bracket.
It doesn't matter. You can put it in front of the bracket, inside the bracket. Doesn't matter. It's all one term. See, it's not separate terms, so it shouldn't change because you have a negative times a negative divided by another negative. So that's 3 negatives. It doesn't matter. This all together, you could have written it as 3 sine x cos x as well. It's the same thing. If you decide you just want to put your number in front, then it would go in front, but you have a negative times a negative, which is a positive, and then you have a sine x and a cos x. And at the bottom, you will have -2 sine x cos x. And then you would cancel those out. And then you left it up. Okay. Any questions on this one, guys? All right, I'm going to give you some to practice on your own, and I suggest that you do practice them, please. So let me just see here. Yeah, this stuff is going to be in the text, yes. Sorry, I'm just looking for the right page here. So exercise 7. On page 147. I want you please to do 1, 3, and 4. All right, so 3 of these types of questions. Tomorrow we're going to carry on with reduction formula, but we're going to work with values only, no x's. And then on Friday, we're going to do the ones where we have 90 and 270 as well. Okay, I'll put it on the board quickly, these ones. All right, that's the page. You are doing 1, 3, and 4. Okay, get going now, please.